4.2 Combining Functions Algebraically, Part 1. So first of all, let's just remember how a function works and what it means to evaluate a function. So if we know f of x is 3 minus 4x plus 5x squared, so that is a quadratic, evaluate f of 0. That means that I'm evaluating the function f at 0, which means that I'm plugging an x in to be 0. And the result is going to be some y value, and that's the evaluation. So 3 minus 4 times 0 plus 5 times 0 is 3, so f evaluated at 0 is 3. Same thing with 2. So 3 minus 4 times 2 plus 5 times 2 squared. So that would be 3 minus 8 plus 5 times 4, so 20. So 15. So f of 2 is 15. 3, let's do a different color. 3 minus 4 times negative 1 plus 5 times negative 1 squared would be 3 plus 4 plus 5, which would be 12. So that would be f of negative 1. So just remember that that's what that means, to evaluate it. And this can be done algebraically as well. So if we're going to evaluate h at 2, that means we're going to do f at 2 plus g at 2. So if I look at f at 2, so that's when x is 2. Remember, we're replacing our x values. My y value is right there at 2. So f at 2 is 2 for y. G at 2 is right here at negative 1. So we have 2 plus negative 1, so the value of h of 2 would be 1. So we don't even need to graph it to be able to evaluate it. So we'll do another one. So we're going to do the difference this time. So difference of 2 is going to be f evaluated at 2, subtract g evaluated at 2. So we already did this. We know that f evaluated at 2 is 2, and g evaluated at 2 is negative 1. So d evaluated at 2 is going to be at 3. And we could graph these to show that this is the accurate thing. So if we added and combined our functions, so this point right here, I would go 0. Here at negative 2, I have 0 and 3, so it's going to stay at 3. The next one we have is 1 and 1, so it's going to move up to 2. We have 0. Okay, that made absolutely no sense. I take it back. Okay, this one's going to be here. We have this point, it's going to be higher, so it's going to be, it looks like 3. So 2 plus 1 makes 3. We have 1 and 1.5, so like 3.5. We have 0 plus this point, so this point. We have negative 1 plus 2, which makes 1. We have negative 2 plus 2 and a bit, which makes lower. Oops. Maybe just a little bit above the line. So this graph's going to look like this. And we already know that h of 2 evaluated is at 1. So there's that answer. So we actually don't need the graph. We can just do it algebraically. The graph just helps us visualize it if you can't visualize it. So for this one, just know that 2 subtract negative 1 would be negative 3. That makes sense on the graph. This graph's actually going to look like this. But we don't need to do all of that work. We're just going to do it algebraically for this lesson. So last one, product of evaluated 2 is going to be f evaluated at 2 times g evaluated at 2. So product evaluated at 2 is going to be 2 times negative 1. So it's going to be at negative 2. So a lot easier to do it algebraically. Graphing kind of sucks sometimes, but it is nice to be able to visualize it to see what that actually means. So if I look at my point at 2, I'm going to take, oops, that's not 2, -1 times it by 2, and I'm going to get -2. So my new point is going to be down there. And just so you know, this graph's going to look like this. Okay, a quotient, same thing. Quotient evaluated at 2 is going to be f of 2 divided by g of 2. We know f of 2 is equal to 2. We know g of 2 is equal to -1, so it's at -2. And just remember that you will have a non-permissible values when you're doing graphs of quotients. We want to know when g of x is 0 because g is the bottom. So because g of x is 0 right here, this is where my asymptote would be. So just keep that in mind. Okay, making an explicit equation. This is important because it combines two equations. So now we actually know what f of x means and what g of x means. So the first part says f of x equals x plus 2 and g of x equals the absolute value of x. State the domain and range of each function. So you don't have to know the graph, but it doesn't hurt to visualize the graph. So x plus 2 is going to have a y-intercept of 2 and a positive slope. So it's quite clear that the domain and the range are element of the real numbers. So it does not hurt you to do a quick sketch of what you think that graph will look like. Absolute value of x is a v. So that's from Pre-Cal 20. So domain is all the real numbers. And range, because it can't be negative because it's got an absolute value, is greater than or equal to 0. And it is important if it says f of x first or g of x first, keep that in mind for some of them. Okay, so we're going to do f of x plus g of x. So we have f of x plus g of x, so we have x plus 2 plus the absolute value of x, and that is our explicit equation. To determine the domain and range of this, what you can do is you can sketch, you can try to combine the sketches, or I'm also okay with you just typing it into Desmos and getting the sketch. So I want you to pause the video and I want you to type this equation into Desmos. So what you should have gotten is a graph that looks like this. So the domain is x is such that x is an element of the real numbers. And the range, you should have got it balancing out at 2. You should be able to figure out the domain pretty easily. Range is a little bit harder because you might not know where those maximum and minimum points are. Okay, f of x subtract g of x. So we're going to do x plus 2, subtract the absolute value of x, and there's our explicit equation. So for our domain of this, if you think about it, if I combine these two graphs, there's not going to be any non-permissible values, and they both start with full domains. So it's going to be x as an element of the real numbers. And our range, you might be able to guess it without looking this up because we did do two absolute value and lines from the last unit. But this one's going to be the opposite, and it's going to have 2 where it bounces off and then go down. So it's going to be less than or equal to 2. Again, if you didn't see that, go ahead and type it into Desmos to see that picture. Okay, multiplying. So we're going to do x minus 2 or plus 2 times the absolute value of x. So a little bit easier way to write it is x times x plus 2. So there's our explicit equation. Our domain is going to be real numbers. It does not change it. Our range, if you don't remember from last lesson, When we combine these, we got a cubic. So if you did not know that, you can type it into Desmos and you should see a graph that looks like this. Oops. So y such that y is an element of the real numbers. And the last one is a quotient. So we're going to do f of x on the top divided by the absolute value of x. To figure out our domain, we need to figure out our non-permissible values, so whatever makes the bottom 0, so x cannot equal 0 for the real numbers. And our range is going to be all the real numbers. If you type this into Desmos, you'd have an asymptote, and it would go like this. Okay, next question. We have square root of x and x subtract 2. So the square root of x, you should be able to visualize that graph. It starts at 0 and then it goes like that. So our domain is x such that x is greater than or equal to 0. And same with our range. And our other equation is a line. Oops. What is it? Subtract 2, so it would look like this. And we know that domain and range for a line are both elements of the real numbers. Okay, so let's do f of x plus g of x. So we would do square root of x plus x minus 2. And that's our whole equation. So square root of x plus x minus 2. Our domain, so if you think about this, if we're combining this and this, it's not going to be able to have any points past here because we don't have any points for our one function. So our domain is going to have to match this first function, so x is going to be greater than or equal to 0 for all the real numbers. If you type this into Desmos, you should see a graph that looks like this. And it plots a point down here at -2. And again, that is also something that you should be able to figure out just with logic. So we know we have a graph that goes like this, and it's 0 and 0. We also know we have a line that goes through 0 and -2. So if I add those 2 points together, I get -2. So that one you should logically be able to reason your way through, because we know where that starting point is. So we really only have to evaluate that section. Okay, let's do subtraction now. So we have the square root of x subtract x minus 2, so which is the same as the square root of x minus x plus 2. So our domain is going to be greater than or equal to 0 for the same reasoning as the last question. If you type this one into Desmos, however, it looks like this, and it goes up a bit first. So this point right here is at 0.25 and 2.25. So if you type that into Desmos, you should get that graph, and it'll help you find your range to know that it's going to be less than or equal to 2.25. Okay, f of x times g of x. So we're going to do the square root of x times x minus 2. And we could distribute that in and say x root x minus 2 root x to simplify. Either way, I want you to type this one into Desmos. Actually, you should know the domain. And it's the same as the last ones. It has to be greater than 0. It matches that restricted domain on the radical function. So pause the video and I want you to type this into Desmos so we can find the range. So you should have gotten a graph that looks like this, that has a local minimum at 0.67 and negative 1.089. So our range for this function would be y such that y is greater than or equal to negative 1.089. And last one is a quotient, so we have the square root of x over x minus 2. So we will have a non-permissible value at x equals 2. We will have an asymptote. Without even drawing this or typing this into Desmos, you should know this looks like that. So our domain is going to be x such that x is greater than or equal to 0, and it cannot equal 2. If you type it into Desmos, you'll see it looks like this. So from what we can tell, it's element of the real numbers. I am less concerned with the range in these questions as the domain. Domain is something you should always be able to find. Range is kind of like an added bonus. Okay, so that's how you combine them algebraically.